in AI fields, including ASR, TTS, and NLP. Let's welcome Xuelu Zhang of Metric Data to start this session.
Okay, thanks for the president. So, hi everyone, welcome to this live session organized by Magic Data. So my name is Xuelu Zhang. I'm the Research and Development Manager of Magic Data, and I will be the host of this live session. So today we are honored to have invited two of our experts in the field of ASR, especially, and Daniel Povey, who is the main developer and maintainer of the famous framework Howdy. And he's also actually the principal scientific consultant of Magic Data. And Chen Gaofeng, who is a researcher in the Institute of Acoustics of Chinese Academy of Sciences. And his research focused mainly on SR, PWS, as well as intelligent speech platform. So this session will consist of two parts. The first part will be a table-round discussion around the topic of data strategy. So in the field of ASR by default, because our experts are especially in the field of ASR. And the second part will be an interaction part. So where our experts will answer some of the questions. So if you have any question or any remark during the live session, you can leave us a message using the chat function of Zoom, and my colleagues will select some of the questions for the interaction part. So now let we start the first part of the live session. So we have chosen this topic of data strategy because in the AI field, most of the time we're talking about the progress and innovation that we have made in algorithms, in models, in frameworks. But relatively, we don't talk that much about how we select a data. However, when we're talking about the performance of a certain model, we are implying, in fact, that we have a suitable data strategy to achieve and re-achieve this performance, right? So for this reason, I think it would be nice for us to have some ideas or some advices from our experts on this issue. As developers, it often occurs that when we decide to train a model, the first thing that comes to us that we find that we don't have enough data or we don't have enough suitable data for the model. So what we do then is try to minimize the need for data of our ideas or any advices on that to how to minimize the need for data of our models.
Before we get to the question, there's something I want to do. I've never been in front of a microphone this professional looking before. Good morning, Beijing. You know that movie, right? Good Morning, Vietnam.
Yeah, exactly.
Okay, so what was the question again?
The question is how to minimize the need for data of our SR models.
Well, I suppose the boring approach is just to use a smaller model. But that's going to lead to worse performance, right?
Yeah, exactly.
Well, what's the obvious approaches?
I have prepared some idea on this topic. I think if your scale of your dataset is limited, so you have to ensure the quality of your manually annotated data is very important. In my experience, the transcription errors, especially like the insertion and the deletion errors, will cause the AS models, especially the recently very popular attention-based end-to-end model fail to converge. Because
that's interesting.
Yes, because the attention-based end-to-end model have to learn the text-to-audio alignment by itself. So the insertion and the deletion errors will cause the misalignment problem.
Which particular types of end-to-end models have you encountered this problem with?
Maybe we can take the listen, attention, and spell, for example. Yes. So, in my opinion, using higher quality training data and appropriate data augmentation techniques, or just as Dan advised, you can reduce your model size.
It's an interesting observation. it makes a lot of sense, because if you have 1,000 hours of data, one small error, the model isn't going to remember that, right?
Yes, the memory will overfeed to that deletion or insertion error.
Cool. Well, I suppose the obvious approach I was thinking of is just to use augmentation, but maybe we're already assuming that there's augmentation. Like, would you assume that there's augmentation naturally?
Yes.
What augmentation approaches do you use?
The second augmentation, we can use the augmentation should be divided by what submodules do you want to augment. For example, if you want to augment your acoustic model, you can use speed perturbation or the spec aug.
Okay.
If you want to augment,
so speed perturbation, like that's something we use standard in CalD.
Yes.
Spec aug, we never got to work in CalD. Like we did for very small data in mini LibreSpeech, but otherwise, for us, it never worked. And I think it must be something about our model, because it seems to work for other people. How about you?
Spec augmentation is, I have tried spec augmentation, didn't work under CalD. Maybe it's because the CalD used frame-wise cross-entropy training. And if you, the spec augmentation will mask a long range of audio.
But it only uses that a little bit for like regularization. I think I assumed that it was something about the smaller models or like the factorized TDNN, but I don't know. Like, who really knows what it is?
Do you think there's a choice to reuse some already trained parameters for
reuse? Oh, you mean like using a pre-trained model?
Yeah, sometimes, yeah, sort of that.
We don't have good recipes for that in CalD, and people don't tend to have very good results. Okay. Lately, I'm starting to think that maybe it has something to do with batch norm. Because the problem with batch norm is that you have to have the same distribution of data, right? Otherwise, the batch norm stats change and your model behaves differently. And I was thinking it might be a good idea to come up with a method to like somehow transform the model so that you can keep the same behavior with the new stats.
Yes.
I don't have time to do that right now, though.
Will fine-tuning help reduce the gap between the training and the test for the batch norm?
Well, I've always, the good results that we've seen are usually with training from scratch. Like we've never seen, it never seems to work that well when you train the already trained model. And I'm starting to suspect that it has something to do with batch norm. Like, I don't think we've tried freezing the batch norm, you know, like converting the batch norm to test mode and maybe combining it with the parameters and then training more. But the problem with that is that it would probably be unstable unless you use very, very small learning rates. I mean, that's a possibility.
How about the renorm?
Oh, the renorm, well, okay. I suppose you could do that. Like CalD has this normalized layer, which is the same as Hinton's layer norm.
Yes.
Although we actually came up with it before batch norm even existed. But it does slightly degrade the baseline results, but it might help with the retraining. I wish I had time to look into all of these things. I'm too busy working on this K2 stuff right now.
Okay. So we have just mentioned about the data augmentation strategy. Surely it's one of the most important, most common strategy that we use if we don't have enough data. But here is a question. Do you think there are limitations of data augmentation? I mean, by limitations, I mean two things. First, do you think there's a limitation of, in fact, of data augmentation on models' performance? And the second thing is, where should we stop the data augmentation action? I mean, if we wish, like, we can augment the data without stopping.
Well, there's definitely diminishing returns, right? I think what people always find is if they're combining different data augmentation strategies, they're always very, very sub-additive.
Mhm.
Like let's suppose you try speed perturbation,
Mhm.
and then separately you try spec
Spec
augment.
augmentation.
Yeah.
Then you get a certain, maybe you get the same improvement, but you combine them, you only get a little bit extra.
Yeah.
Will it, if you will train for more apples, will it help?
I don't think it helps that much. My experience has been that augmented data is never as good as real data.
Mhm.
But I think we're talking here about simple augmentation that it's basically you take the original data and you do something to it. You add reverb or you
Yes.
add noise or you speed perturb.
Mhm.
But weren't we talking earlier today about some kind of a TTS based thing?
Yes, yes.
What was that? Where did you hear about that?
It has been proved that the TTS-based data augmentation, which we can use the multi-speaker
Mhm.
TTS system to generate the audio from the text-only data to augment the ASR system, has been proved useful for the
Who did this?
Google, yes, has been proved to be beneficial for the voice command and voice search tasks.
Oh yeah, but you were saying that for speech recognition, it was making things worse.
Yes.
I suppose the amount of data isn't the issue for Google, clearly, because they have all the data they want.
I think the reason why is the TTS method harmed their performance for the CTS task because it was challenging to generate real freestyle talk.
Real what?
Real freestyle, like CTS.
Oh, okay.
Like in real.
Okay. I mean, I suppose TTS systems don't try to generate disfluencies normally.
Yes, disfluency is difficult to be generated.
Yeah.
I have one question for you. Some people said that the spec augmentation is just another kind of dropout. Spec augmentation. How do you?
Well, I don't know. I mean, I'm sure you could formulate it as a very special type of dropout on the first layer.
Yes. What's the difference?
Well, I suppose normal dropout, it's normally independent, right? Like each frame gets its own dropout mask.
Yes.
Whereas with spec augment, you're taking out whole chunks.
Continuous.
Yeah. So for me, it's very strange that this even works. Like you would think it would confuse the model to have these big chunks taken out of the data and to still have to predict that word when the word isn't even there. So someone, I was moderating this interspeech session a couple of days ago, and someone had the paper where they were taking, it was like spec augment, but they were taking words out, like they were aligning it.
Semantic spec augment.
Yeah, they were aligning it with the words. And what I would have expected is that it would make sense to do that, but then also take out the word.
Yes.
But they weren't doing that.
You think the semantic spec augmentation is more reasonable?
Well, I'm just saying that if I were to think of that, my first instinct would be to remove the word from the transcript, so that it's not trying to predict something that isn't there.
Randomly to remove.
Well, no. Well, you can still remove the word randomly, but I was saying take it from the audio, but also take it out from the transcript.
Okay.
But maybe for some reason I don't understand, you have to leave it in there. I don't know.
Do you think the semantic spec augmentation can be easily done under the so-called end-to-end system like Lattice? But it seems, how can we integrate such interesting technique under KLD or K2? Because KLD uses the triphone.
Well, I mean, doing it kind of it's not hard to do spec augment if you just mean like implement it. Like we already have the code. We don't normally use it because
not useful.
It doesn't really seem to help.
Okay.
I don't know. I'm not a big believer in these. So are you a believer in LAS, listen, attempt, spell? Like, are there some applications where it works better than a standard system, like a hybrid system or Caldi style system?
I think the fine-tuned, the best tuned hybrid and the best tuned end-to-end should be no difference. Also, the hybrid should be better, but for some real large-scale data sets, it may be some mistranscripts. This may do some harms to the alignment of the hybrid system. Also, to build a system, to build an ASR system, we don't have some linguistic experts to provide a very precise lexicon. So I mean, this may be the biggest obstacle.
Okay, but isn't that a separate issue? Like, couldn't you build a standard, like Caldi style system with lattice free MMI and cross entropy, with like a lexicon that was just the characters or something?
Yes. Like, end-to-end lattice free MMI.
Yeah, I guess, but with the characters as words. Like, is your experience that for that kind of lexicon, these so-called end-to-end topologies work better? Is that something? I mean, have you noticed that if you're using like not a good lexicon,
yes,
this listen attend spell works better?
We're not using that good lexicon.
Yeah.
yes.
Oh, okay. Okay. Forget about that.
Okay, but we have tried with the not that good lexicon models. It still work in the hybrid system,
as well.
but not that well.
Okay.
The performance cannot prove anymore.
Cannot improve
anymore, even we put more data or good quality of data in it.
Really?
Yeah.
Okay.
So the
and have you also tried with end-to-end methods, so-called end-to-end methods?
Not yet. Not yet. Because end-to-end could be using a word piece models.
Yeah.
So
I think there was a paper in the interspeech session where somebody had something about that. It was some kind of end-to-end, maybe it was RNNT, and they were trying various lexicons, including a word piece one and also like letters in context. And I seem to remember they both were working okay.
Yeah.
I think they had tons of data, which is maybe why. I mean, it's possible that these things like RNNT are better at dealing with like poor lexicons or the situation where your lexicon is not, it's just letters or something.
Okay.
And we tried this stuff in Caldi. We messed around with different types of lexicon, but for us, it was always better to have the real lexicon, like with phones.
Of course.
Yeah.
Okay. So here's another question for you. That sometimes as developers, when we don't have enough data, what we do is that we try to explore the raw data that we have collected. If we have.
Okay, when you say raw data, I think you mean like untranscribed data.
Yeah,
right?
exactly. And maybe noisy.
Okay.
Collected under all kinds of acoustic environments.
Yeah. So what you're wondering, like, what's the best method to train on that?
Yeah, exactly. For those who have to explore this kind of data, I'd like to ask, how can we identify the raw data that we can explore or have the potential to be explored? And what kind of raw data we have to reject?
Oh, I see. So are we mostly talking about which data should we transcribe?
Yeah, or something like that. Or maybe use for non-supervised way in a
which part of the data will improve the system more?
Yeah, exactly.
You know, there's been research like a long time ago, probably before you guys were going to conferences, about this kind of topic, like if we have to transcribe some data, which do we want to transcribe? And I think what they've generally found is you don't want to pick the really easy data and you don't want to pick the really hard data. Because the really easy data, your system is already doing well at that.
Yes.
And the really hard data is too hard. So you want data that's like in the middle, Goldilocks data.
Okay.
Middle class data.
Maybe, yeah.
By easy and hard, it means exactly what For example, acoustically is intelligible?
Yeah, I guess. I think the way you would measure this is probably like lattice confidence or something.
Okay.
Like you'd get the confidence in the CTM.
Okay.
And you know, if it's low, then you say the data is bad, or if it's high,
okay,
the data is good.
okay.
So I believed for a long time that we could get a lot of improvement if we have a really good confidence estimate, but it's always been difficult to do that within Kali just because the framework doesn't make it so easy to, let's say, run a neural net on top of the lattice. That's part of why I'm developing K2, which is because I want to make it easy to do all kinds of complicated things after the first pass decode and not have, and basically have it like writing a PyTorch model,
Okay.
that you can just do this, then do this, and it's just all in one program, and it's easy to work with.
Yes.
Okay, thank you.
Very exciting.
So do you have any thoughts about this?
I have
question?
limited experience in this topic, so.
Well, I don't have a lot of experience in selecting data. Like usually, because I'm in academia, usually we deal with data sets that have been collected. So that,
Okay.
yeah.
That are open to us to clean and to choose the data that we who have the potential to be clean and who have the value to be mined.
Well, I suppose the first thing is just to throw out the silence and the noise.
Yes, exactly.
And it's surprisingly non-trivial. Like you would think voice activity detection was super easy, but it seems that in practice it's not as easy as you might think.
Okay. Yes, exactly. So let's go to the last question of this discussion. Is that if we have to pre-train a model, to pre-train SR model, suppose we have to do that.
Yeah.
And what, according to you, what kind of speech data should we select for that to assure the good generalization of the model, for example?
My bias would be towards using data from the same language that you're interested in, because I just don't see any point wasting like parameters on learning other languages.
Okay.
But maybe from a good variety of acoustic conditions.
Okay.
Because although the models are very sensitive to that, like you change the microphone to a human, it would sound the same.
Yes.
But to your model, it doesn't always. What do you think? Do you have any experience with this?
I have some question for you. How do you think about the unsupervised pre-train?
Unsupervised. Oh, I
do you have plan to support it under K2?
Okay, you're thinking about things like WAV to letter, I guess.
Yes. Wave to back.
Oh, sorry, yeah, word to
Wave
back.
to back.
Well, I don't know. I guess I'm open to the possibility. Like, in practice, you tend to care about the size of your model, right?
Yes.
So, like, it just seems like unpractical to train a huge model. And I think in practice, you only see significant improvements with this pre-training if you don't have much training data.
Yes.
I guess my attitude is that if you're actually serious about building a speech recognition system, you can afford to collect 20 hours of data. You know what I mean? But it's still interesting from a research point of view.
Yeah.
But I just don't know that it's at a practical level yet. Like I feel like to get improvement from that, you'd either have to have your model so big that it's not practical to use, or to have so little training data that you can't build a good system anyway.
Yes.
Okay. So sorry for that, but it's time to go to the second part, which is the interaction part. So we have collected some questions from our audience, and we don't have too much time, so we will just take a couple of questions. The first question is, this is for them. I have trained a model on our own data with Kali. If I got a chance to get more new data, how to know what data is useful for our model? What should I do to announce this new data?
Well, the thing is, what's useful kind of depends on what your test data looks like, right? Or on what data you plan to use it on. I would just focus on like things that people are saying in your application that maybe isn't reflected in your training data, or maybe things that you're having trouble decoding accurately, but that, you know, are still common or still intelligible.
Okay. Okay. The second question is, can acoustic front end be replaced by neural network, for example, AEC beamforming? According to you.
What do you think about this?
I have no idea.
I'm not a big believer in this. Like right now, everyone wants to be end to end. Like it feels like people don't even want to drink a cup of coffee unless the coffee is end to end. That's probably something bad, isn't it? But like I'm still a believer that there's something in these old-fashioned approaches of like, obviously it requires more math, right, to do it the old-fashioned way. But like acoustic echo cancellation, it seems just like a simple linear problem. And yeah, you can train on 1 million hours of data and a neural network can learn to solve a linear equation maybe. But couldn't you just do it much easier by doing it the obvious way? That's my attitude. And beamforming too, it seems like it's one of those like exact linear problems that you probably want to like, you know, accumulate a variance and like solve some equation. I just feel like neural networks aren't the right method to do this, but in practice, they might be easier to get to work than doing it the right way. Like, so in the next generation, you know, tools that I'm working on, I want to make it easier to do this. So the data preparation, that part is called Lattice, and we're trying to make it easy to deal with data that has multi-channel.
Yes, exactly.
But I don't think we will be able to like personally write those algorithms because I'm not an expert in this multi-channel stuff. Like it's a very specialized area, but I feel like those people have something to contribute. So I'm hoping to make it easier, you know, for them to put their algorithms inside our.
Yes, exactly.
Yeah.
Okay. Do we have time for a third question? Okay. The third question is for Dan. Could you please talk about the plan for public PyTorch version Caldi?
Okay, so, you know, since the time when we were talking about like a PyTorch version Caldi, plans have moved on a little bit because, so the original plan was just to take the graph parts of Caldi and put like a Python layer on top of it and then have the model be a PyTorch model. And we kind of got that working at the prototype level. But I kind of came to the conclusion that it would be too much work for too little benefit to do that, because you'd have this, the system would have too many parts to maintain. It would be too complicated. The script structure would be ugly. I felt that if we just start from scratch, we can do everything right, like, and not have to deal with all of this accumulated complexity. So that's why we're starting from scratch. And I'm hoping to have something that actually works within the next few weeks. Like, so the K2 project is like this finite state stuff. It's going to be the core part of it. And we've almost finished. Like it's almost working. Soon you're going to be able to train like CTC and Lattice for MMI. Currently it just supports PyTorch. But what K2 does is it's just like this differentiable finite state acceptor. It's kind of an extension to PyTorch. So you can use these objects that support like composition and taking expectations and stuff. And it's basically, it will allow you to implement things like CTC and Lattice free MMI much more easily, and then decode much more easily too. And it'll be efficient on GPU. We put a lot of effort into that. Makes it much more complicated, but to implement for us. But it's should be very fast.
Okay.
Yeah, hopefully like within a couple of months, it'll be like actually useful and usable. But within a couple of weeks, we hope to be releasing like, you know, example scripts. We'll try to make it to like, on GitHub, it's like K2. I think it's K2-ASR is the project name, and then K2 is the repo name. And once we have something that's usable, we'll make it clear there. But right now, I don't want people going there and asking like dumb questions like, how do I install this? Like, if you're a really good developer and you want to help us develop it, then follow it on GitHub and try to understand what we're doing and make a pull request. But right now, it's not ready at the user level.
Okay, thanks a lot. Unfortunately, we have to close this live session. So if anyone is interested in finding the dataset who fits your model, you're welcome to come to our virtual center online. For more information, Magic Data is experienced in data collection and annotation. And by now, we have already cooperated with dozens of technology companies all around the world. We have reserved 100,000 of hours of speech data, and we have the capacity to process speech data in more than 50 languages. And recently, we have updated our catalog with conversational speech datasets as well as open resource datasets. So if you're interested in all this, you're welcome to our virtual stand. And thanks for everyone's attention. Thanks for our guests again. And I'll give back the microphone to the president.
Okay,
Bye.
thanks. Yeah, thanks to Magic Data and thanks to Dan. Okay, yeah, we will have a 15 minutes break. Then we will have Meituan and Alibaba after the break. Okay.